for this session, we're going to look at integration by what's called parts. So, if we consider the function, or consider the problem, determine the integral of x times cos x dx. We've got two functions of x multiplied together. It's requiring the integration of a product of two functions. We had a product rule in differentiation. So this is similar to that, but there's a bit more of a process involved than there is. The differentiation ones just use a formula. This one involves a bit more of a process. I.e., the cosine of x is a function of x, which in this problem is then multiplied by x, which is another function of x. In order to integrate this type of function, you need to use the formula for integration by parts, which is the integral of u with respect to dv is equal to u times v minus the integral of v with respect to du. Doesn't make much sense when it's put in front of you like that, okay? But u and v are both functions of x. The use of this formula also requires a procedure as followed, which is best demonstrated by example. So we go through an example or two, and then I'll give you some to have a go at. Usual kind of format. So, first of all, there is a need to assign the two functions to the variable u, the variables u and dv. Doesn't read very well, that's what it should say. There's a need to do this carefully, which will become apparent in future examples. So it's not always an arbitrary choice that we call u one thing and dv the other. There may be a reason why you need to select the right one for the right variable. We'll show why that happens later on. The idea is that you make the choice so that the integral on the right hand side of the equation of the parts formula on which we can integrate from standard. It's not necessarily an arbitrary decision. So the example we're looking at is to find the integral of x times the cos x with respect to dx. I'm going to split the board as one of these where we're assigning two variables. I'm going to start off by saying let u equal x over that side, and over this side we get dv equal cos x. Over this side we differentiate. Du by dx is equal to, and if we differentiate just x on its own, we get 1. Yeah. And then we rearrange to du is equal to dx. It's on the left-hand u side. Over this side, we integrate to find v. So we do v is equal to the integral of, we got that there too, the integral of cos x dx. What's the integral of the cosine of x from your tables? v is equal to sine x. We'll note there that there would be a constant of integration here, but we can add it at the end. Okay, so I'll make a note of that in blue. There would be constant, but it can be added at the end. Okay, all happy with that so far? What we then do is we take this formula for integration by parts. That's got the integral of u times dv is equal to u times v times, minus the integral of v du. Spread it out so we can put all those parts in and bring them together. So what have we said u is equal to earlier on? X. So the integral of x times dv we called cos x. So that's the integral that we're looking for, and that is equal to u was x in the first place, times v is sine x, minus the integral of v sine x du. Now, put dx here. That is dx. I should get that wrong. So we put all that in. Okay. So all we need to do now is, can we solve this integral? It's the integral on the right hand side of the equation, needs to be solvable using the standard tables. So have we got a table of sine, an entry for integral of sine x? So the final answer to this is x sine x. What is the integral of sine x? Minus cos x. And then we'd put our plus c on. Okay, and those two negatives there become a plus. So the final answer is x sine x plus cos x plus c. Follow that? Not too bad.